So we have our discussion why we have put that data section in ROM. Okay, we have previously. So now we will see why we are also putting one data section here also in the RAM also. Why we are keeping that data section in RAM also. We will see now that thing. So we will see the code again. Okay. So we have basic code here. So this value. So this value int x is equal to 10. Okay, I have stored that in data section here. Okay, in ROM section. But what if I want to change that value? Okay, what if I want to change this 10 from x is equal to 10 to x is equal to 20 or something, anything? Okay, how can I am able to do that? Because it all of a sudden the value of x is equal to 10 cannot be modified, because that value is stored in RAM section. Okay, in the RAM section. So from RAM section I cannot change the value suddenly. So what happened is that we have a RAM, okay, and during the boot up of the microcontroller there will be some piece of code that copies the values of data section from ROM to RAM. Okay, so now concentrate on one thing or focus that I am explaining you now, that the trick that is used in a linker script world, what we say is, when you are generating binary, use the load addresses of ROM. Okay, but in the code when we are doing modification of the value x, here I am taking x, that is that is 10. Okay, when you are doing a modification, use the address of x, that addresses of x should be from RAM section. Okay, we will see this thing that just now I have said in broader way. I am drawing that RAM and ROM section. Okay, so I have here, I am drawing it bigger because you should understand what I am doing here. Okay, here I have ROM, I have RAM, then I have data section or data section. Okay, here I'm just drawing rough diagram. Okay, so I have taken the values x 120, these values are loaded here. Okay, then I also have text section in ROM only. Okay, dot data section and text section. Okay, here also I have dot data section, that's what we have discussed till now. Okay, so again here so in text section we have code. So you know that data section is placed in both ROM and RAM. Okay, now concentrate what I am saying. The load addresses is generated for ROM. Okay, load addresses are generated for ROM, and logical addresses are generated for RAM section. These are important terms, load addresses and logical addresses. So during the binary generation compilation phase, the values from this data section are, here I am 10 and 20. Okay, put these values from ROM section to RAM, 10, 20. So how it's done, In ROM section you can see we have text section where the code is saved. Okay, in that part there is some part of code, the initialization, the code that we can also say the initialization part, which will say take the data section from the load addresses and load or transfer into something called logical addresses. Okay, so we can also draw a rough here. This is the part of code, initialization code, that take the load values from load addresses and put it into RAM or logical address of RAM. Okay. I also want to explain you that this region, RAM region, is called ROM region, it's called load address region. Okay, and this part, that's the RAM part, it's called logical address region. So you should know these things. So the code makes the reference to the globally initialized variable with their logical addresses. Okay, so you can imagine two places that the value of x or any global variable exist on ROM and RAM also. Okay, but the code that will always use the addresses that is pointing to the RAM or the logical addresses. So now what happens when we are modifying x? It is getting modified in RAM and the code using the RAM's location, that is logical address. So this is the process. So when we see that when we reset the microcontroller, okay, what happened is that next time it is booting the data section of ROM. During the booting process, the data section of ROM get copied into data section of RAM. It is a bit confusing, but I have explained in easy way, I think. Okay, that's all for data section.